Hello young intellectuals! Welcome to Project Stay Curious. Ang lesson natin in this video is about significant figures. Simulan na natin. Marami sa atin ang nalilito sa rules ng significant figures. Kaya madalas, we decide not to include significant figures in handling numbers. Katulad sa mga exam na merong computations, most of the time, we are just required to express our answers in 2 decimal places or in 3 decimal places just for them to look more accurate and for uniformity ng answers natin. But the question is, do our answers really become more accurate if we express them with more decimal places? Well, significant figures mainly focus on making meaning out of numbers. Significant figures are defined as meaningful digits in a measured or calculated quantity. Kung ang numbers sa quantity na ating i-measure involve integers only, halimbawa, counting the number of students in a class, it is possible for us to get exact value. But this is not always the case in scientific investigations. Hindi sa lahat ng pagkakataon, integers or whole numbers ang numerical values na ating nakukuha. That's why, by indicating the significant figures in measurements, the margin of error, defined as an amount allowed in case of miscalculation, is given importance. Kapag gumamit tayo ng significant figures, the last digit is understood to be uncertain or in Filipino, hindi tiyak, hindi sigurado o alanganin. Halimbawa, nag-measure tayo ng liquid using graduated cylinder with a scale that gives an uncertainty of 1 milliliter in measurement. By the way, uncertainty in measurement is expressed in this form. Kapag ang volume ng liquid na ating nakuha ay let's say 9 milliliters, then the actual volume is in the range of 8 to 10 milliliters. We represent the volume of the liquid as 9
plus or minus
1 milliliters. In our example, we only have one significant figure, which is the digit 9. I-discuss ko ang rules for significant figures as we proceed with the lesson. For greater accuracy, maaari tayong gumamit ng graduated cylinder with finer divisions so that the value of uncertainty will be reduced to 0.1 milliliter. Kung ang volume na ating nakuha ay 9.0, we may express this quantity as 9.0
plus or minus
0.1 milliliters. And the actual volume is now somewhere between 8.9 milliliters and 9.1 milliliters. In this situation, na-increase na natin ang accuracy ng measured volume. We can further improve the measuring device that we utilize para mas makakuha ng mas maraming significant figures. But again, in every case, the last digit is always uncertain. And the amount of uncertainty ay laging dumedepende sa ginagamit nating measuring device. Ngayon naman, let us talk about the guidelines for using significant figures. Sa ating scientific works, mahalaga ang significant figures to increase their accuracy. In general, madali lang naman ma-determine ang significant figures in a number. Kailangan lang natin sundan ang mga sumusunod na guidelines. Number 1. Any digit that is not 0 is significant. For example, we have 876 centimeters. Meron itong 3 significant figures kasi ang mga digits ay hindi 0. Another example, let's say we have 23,876 grams. Meron itong 5 significant figures. Number 2, zeros between non-zero digits are significant. Halimbawa, we have 403 meters. Meron itong 3 significant figures. Kasi ang 0 ay located between 4 and 3. Ang 4 at 3 ay non-zero. So counted as significant figure ang 0. Another example, 2,002 milligrams. So meron tayong 4 significant figures.
Number 3. Zeros to the left of the first non-zero digit are not significant. Ang purpose ng mga zeros na ito ay for the placement of the decimal point. Halimbawa, 0.12 liter. Meron lang itong 2 significant figures, which are 1 and 2. Yung 0, nasa left side siya ng 1, which is our first non-zero digit, kaya hindi siya significant. Another example, 0.000345 kg, meron itong 3 significant figures lang, which are 3, 4, and 5. Yung mga zeros sa left side ng 3 ay hindi significant. Number 4. If the number is greater than 1, then all the zeros to the right side of the decimal point count as significant figures. Example, we have 1.2030 grams. This number is obviously greater than 1. So ito ay mayroong 5 significant figures dahil isasama natin ang dalawang zeros which can be found at the right side of the decimal point. Ang 40.097 meters naman ay mayroong 5 significant figures. Number 5. If the number is less than 1, zeros between non-zero digit and the zero at the end of the number count as significant. Example, we have 0.080760 minute. Obviously, this number is less than 1. And yung significant lang na zero dito ay yung nasa gitna ng 8 at 7 at yung nasa right side ng 6 at nasa dulo. So in this measurement, we have 5 significant figures. Another example, 0.0330 meter. So we have 3 significant figures. Number 6. For numbers that do not contain decimal points, the trailing zeros may or may not be significant. Ang ibig sabihin ng trailing zeros ay yung zero after the last digit. Example, 1,400 centimeters. Sa 1,400 centimeters, pwedeng 2 significant figures or 3 significant figures or 4 na significant figures. Pero sa mga ganitong numbers, medyo confusing siya kung ilan ba talaga ang significant figures. To prevent the ambiguity, we can express 1,400 in scientific notation. Review lang natin na ang scientific notation ay may 3 parts: coefficient, the base, and the exponent. So ang ika-count lang natin ay yung coefficient. So for 2 significant figures, 1.4 times 10 raised to 3. So 1 and 4 lang ang significant. For 3 significant figures, we will have 1.40 times 10 raised to 3. So ang significant figures ay 1, 4, and 0. For 4 significant figures, we will have 1.400 times 10 raised to 3. So we will have 1, 4, and 2 zeros as significant figures. Ang ikalawang set ng guidelines na ibabahagi ko ay handling significant figures in calculations. Number 1. In addition and in subtraction, the number of decimal places of the final answers must be the same with the original number, having the least decimal places. Kung masyadong marami ang decimal places sa final answer, kailangan itong i-round off. Halimbawa, 10.2 plus 8.45, the answer is 18.65. Yung 10.2 and 8.45 ang ating original numbers. So sa dalawang original numbers, ang 10.2 ang may least number of decimal place, which is only 1 decimal place. So dapat, isa lang din ang decimal place sa iyong final answer. So i-round off natin up to 1 decimal place and the result will be 18.7. Dapat knowledgeable na rin kayo sa rounding off numbers. In multiplication and division, the number of significant figures of the final answers must be the same with the original number having the least number of significant figures. Example, 12.5 times 4.2 is equal to 52.5. Sa ating original numbers, 4.2 has the least number of significant figures na meron lang 2. So dapat ang final answer nyo ay 2 significant figures lang. Kaya i-round off ulit natin and the correct answer will be 53. Number 3. Exact numbers obtained from definition is considered as infinite number of significant figures. Example, 1 inch is equal to 2.54 centimeters. In doing calculations, ang 2.54 ay hindi dapat i-interpret as number with 3 significant figures dahil hindi naman ito measured quantity. Number 4. In chain calculations or calculations involving more than one step, it is advisable not to round off that answer after each step to make your final answers more accurate. Example, 250.0 times 4.0 close open parenthesis, divided by 2.00. So the final answer must have two significant figures lang kasi ang number with least number of significant figure ay 4.0. So ang final answer dapat ay 5.0 times 10 raised to 2. That's it. To summarize our lesson, significant figures are important in the accuracy of our scientific works, and handling numbers with correct significant figure is a required skill for all students. Thank you for watching this tutorial, and always remember to stay curious.